Okay, let's unpack this a bit. What if your dreams aren't just, random brain static? What if they're actually like a window into memories, but stored holographically and lit up by tiny neuron sparks? It's a really compelling idea, actually. A hypothesis people have been looking into for, 2 decades now, linking dreams right to this concept. So our mission today in this deep dive is to see how this uh, quantum holographic dream theory stacks up against modern neuroscience, maybe even ancient wisdom, and the frontiers of consciousness research. Is it? Is it actually feasible? Okay, so starting at the core idea, memories stored like holograms, and these neuron sparks activate them, bringing them into our dreams. How does that really fit with what neuroscience already tells us about memory?
That's a great question because honestly, classical neuroscience already paints a picture of memory that's incredibly distributed, very dynamic. I mean, think about memory engrams, the physical traces. They aren't in one spot. They're spread out across huge networks, different brain regions. We call it an enneagram complex.
Right, spread out.
Exactly. And this distributed nature,
Well,
it's actually a pretty neat structural parallel to a hologram, where the information for the whole picture is kind of contained in any big enough piece.
like Carl Ashley's old experiments.
Precisely. His lesion studies back in the day, he'd remove parts of the brain, but couldn't completely erase specific memories.
Hmm.
It strongly suggested storage wasn't localized.
Hmm. Okay, but dreams aren't all the same, are they? We have those really vivid, sometimes totally bizarre REM dreams, and then the more, logical NREM dreams. How does this holographic idea explain that difference?
Yeah, that's crucial because the type of dream you have is directly tied to very different neurochemical states in your brain and which circuits are active or inactive.
Okay.
So during REM sleep, for example, your frontal cortex,
Mm-hmm.
the bit that handles planning and logic, is largely offline. The brain isn't just passively showing a hologram. It's actively constructing the dream from these activated memory fragments. And that construction process is heavily influenced by the brain's state at that moment, which parts are running the show.
Okay, this is where it starts to get, really interesting, potentially blurring lines. The quantum holographic theories themselves. We're talking about people like Carl Perban, right? His holonomic brain theory. The brain as a holographic storage device using electrical oscillations.
Exactly. Oscillations in the dendritic webs holding information holographically. And then you've got the Penrose-Hameroff or model suggesting consciousness itself might come from quantum computations.
Yeah.
Deep inside neurons in structures called microtubules.
It sounds almost like science fiction. But there's always been that big criticism, hasn't there? The brain is too warm and wet for delicate quantum effects.
Oh, absolutely. For years, that was the standard pushback. How could quantum coherence possibly survive in a biological environment? But here's the twist. Recent quantum biology findings are challenging that assumption. Things like superradiance observed in certain proteins.
Yeah.
It shows quantum effects can happen and persist in biological systems.
Oh, okay. So it lends some biological plausibility, maybe.
It definitely opens the door. It suggests that maybe quantum processes are relevant to how our brains actually function, even if it seems counterintuitive.
So tying this back to dreams, and maybe even older ideas, I'm thinking about ancestral wisdom, things like unlimited associative learning, suggesting consciousness isn't just us, but widespread in nature.
Right. And if you look across cultures, many ancestral and spiritual traditions see dreams very differently. Not just brain noise, but maybe divine messages or accessing ancestral knowledge.
Or even soul journeys, like in shamanic practices.
Exactly. Or cultures with polyphasic sleep. It points towards this idea of a non-local memory, something collective or transpersonal that goes beyond just one brain. It resonates, interestingly, with physics concepts like David Bohm's implicate order, the idea that reality itself might be fundamentally holographic.
Okay, so let me see if I'm getting this. These neuron sparks could be like the biological tuner, your individual brain tuning into this bigger holographic reality, and then the specific dream you have, whether it's REM or NREM, is shaped by your brain's own activity state at that time.
That's a plausible way to frame it, yeah. But here's the major hurdle. How do you actually prove it? Especially integrating those ancestral perspectives.
Right.
Empirically, we're just not there yet. Our current tools, like fMRI or EEG, they measure classical neural firing. They're great,
Yeah.
but they can't directly see or manipulate quantum events happening inside a living brain.
So what we need then are breakthroughs in quantum biology to keep finding these effects, and maybe totally new neurotechnologies, ones that can probe quantum states in living tissue.
That's essentially it. It's a real scientific frontier. It's going to take some serious interdisciplinary work, Physicists, biologists, neuroscientists, maybe even philosophers, all talking to each other.
Well, this deep dive into the quantum holographic dream theory, it really does push the boundaries of how we think about the brain, memory, consciousness. It's this fascinating mix of ancient ideas and really cutting-edge science.
Absolutely. And while solid proof might be a ways off, just consider the possibility. The idea that your dreams, your personal dreams, might be you tapping into a vast interconnected holographic universe, maybe through those tiny neuron sparks. It's definitely something to mull over. What if consciousness isn't just generated by your brain, but is a fundamental aspect of reality that your brain learns to tune into? That's a thought to sit with.